Example 5, the extreme value theorem. It says this: if a function f is continuous on a closed interval, meaning x values between a and b, that f must have a maximum and a minimum value between those values. Now, here's one thing that's wrong with this picture is when you check this, we're going to look for what's called a critical point in a second. And these points right here would be called critical points. Anywhere the graph changes is a critical point, and it's going to happen when the derivative equals 0. Critical point. So you have a critical point. A critical point, I should say this, a critical point occurs when the derivative of the equation, so I'll say when the derivative, or f prime, it equals 0. So anytime you equal 0, you have a critical point, and we will also test on the bounds a and b. On this problem, or this picture, what's actually wrong is this point right there would be considered the minimum. That is the minimum. Though this is a local minimum, that is a local minimum. The actual minimum of the graph would be this point right there. Or you could say a relative minimum. This would be the absolute minimum between a and b. This would be the highest point. That's higher than that point. That is the highest between the bounds of a and b, the highest in the interval. But that is not the lowest. The lowest would be that point right there. So let me put it as a black dot so you can see that this black dot is lower than this black dot. So that would be considered the minimum. This you wouldn't consider because it's outside of the boundary a and b. Okay, so here it says we have a trampoline. The height in feet of a person jumping off a trampoline can be defined by h of t here on the interval 0 to 3. So here's our graph. This is 1 second. This would be 2 seconds. This would be 3 seconds right there. And we want to know the maximum and minimum heights. Now, looking at the picture, we can establish really quickly, this is the maximum. Between times 0 to 3, that's the maximum. That's the minimum. Now, how would you find this if you were using algebra? So I showed you graphically. Well, what you would do is you would take first you'd solve for the derivative. So when I take the derivative, that's a constant, it disappears. This has a power of 1, so 1 multiplies with 5. So you have 5, t becomes the 0 power, so it's gone. So we just have 5 minus, the 2 multiplies with this 2, so 2 times 2 is 4, and t drops in power from a 2 to a 1. So there's my equation. So to find the critical points, what I'll do is I'll say 0 equals, this is for the critical point. This one only has 1. So I shouldn't say point since there's only going to be 1. The reason I know it's only 1 is because we only have 1 power here. Equals 5 minus 4t. And so when I solve this, I subtract 5. And I have negative 5 equals negative 4t. And when I divide by negative 4, we'll find out that these negatives will simplify with one another, that t equals 5/4. That is a critical point, 5/4. And so now when you test for minimum and maximums, you need to plug in these values as well as the boundaries, which in this case, this would be boundary A. We'll call this A. And this one's B from the model, that picture. You need to plug in the points. Now we plug in A, B, and the critical points, which in this case, again, is only 1. So let's first plug in the A. When I plug in the A, what I have is in my original equation, A is, plug in A, we don't know what A is. A is 0. Let me plug that. Okay, so now when I plug this into the equation, H, we want to find the maximum minimum height. So I'm plugging it into the original function H. So I'd have H of 0 will equal 4 plus 5 times 0 to the first minus 2 times 0 squared. Multiplying by 0 is always going to be 0. So that's 0. That's 0. We have a height of 4. Notice this height is at 4 at 0 seconds. Okay, now I would plug in the B value, which B is 3. So let's plug that in. H of 3 is going to equal, and this would probably be quicker if I just use the calculator, but I'll write it out. 4 plus 5 times 3 minus 2 times 3 squared. Okay, PEMDAS says I need to do this parenthesis first. 3 squared is 9. Multiply that times 2. That's going to be 18. Let's go over here. We have a 15 plus a 4 is 19 minus that 18. I'm getting 1. And so at 3 seconds, I should just have a height of 1. Yep, that looks good. And now we plug in the critical point. So I'll just do CP, critical point, which we said was 5/4. So I want to plug in 5/4. And what do we get? We get 4 plus 5 times 5/4 minus 2 times 5/4 squared. So when I do this math, let's see, those 4 plus, that's going to be 25/4 minus, that's going to be 25 over 16. 2 will cancel with that. It'll be 25 over 8. And so when I get a common denominator here, it looks like everything will go into the denominator 8. This will be, when I multiply it by 8 here, I'll have 32 over 8 plus 50 over 8 minus 25 over 8. Basically, it's going to be 32 plus, that's going to become 25 over 8, which I'm getting that to be 57 over 8. Okay, 57 over 8 happens to be a little bit more than 7. So that's a little bit more than 7 there. Let's just write this over here. And now I'm going to show you why I said it would be quicker if I would use this calculator here. H of t equals 4 plus 5t minus 2t squared. And let me get the table. We want the value 0, we want the value 3, and we want the value 5/4. I don't need those. That value right there is 57 over 8. 7.125. Okay, when you look at these three numbers, you can see that this one is the minimum. This one is the maximum. And so that's what we were tasked to find, the minimum and the maximum. Whereas the third value is just a value that's in the middle somewhere. It's not the extreme value. These are the extreme values. And that's what the extreme value theorem said, is there will be a maximum and a minimum. So there's the algebra of how the calculator would solve that. Now I have one for you to try. Pause the video if you need more time. Here's your A, here's your B. You're only looking in this interval. Again, you could graph this like looking in here. We could have said these are those critical values. I got that by going to table and typing in, that's my A, that was my B, and this is my critical point of 5/4 that we found. For you, again, what you would need to do is take the derivative, set it equal to 0 to find your critical point.